Hello, hi, welcome everybody to this brand new summer session of Math Masti and More, brought to you by Khan Academy. Now, I am, as usual, very excited to start this session, and I can see a lot of you are here excited as well. So, quickly tell me that I am audible, I am visible, there is no technical issues whatsoever, everything's good. Give me a thumbs up in the chat and good afternoon, everybody. Okay, so quickly tell me with your thumbs up, tell me everything's good. Yes, ma'am. Let's go ahead. Let's get this session rocking. Yeah. All right. I can see all of your chats from here, by the way. Okay. So, okay, Shivam is here. Hello, Shivam. Hi, good afternoon, Gajendra. Hello. Hi, Kuver. Hi, Gulshan. Gulshan Kumari. Okay. Hello. Hi, Bhakti Sagar. Okay, Kuver Singh is here. Oh, weren't you there in the last session also? Okay, awesome. Ramesh Patel is here. Hello. Hey, Gajendra. Okay. Now, quickly tell me. All good, all good. Yes, all good. Okay. I am going to assume that, yes, I am perfectly visible, perfectly audible. And this over here is, yes, our entire series summer series last session. Yeah, so let's make the best of it. And here is the schedule for English sessions that you have all followed, right? So even if you have not been able to attend the live class, why not? You can go ahead and look at the videos that are there in the app under the live section. Okay, so all of these lives, they are there already in the playlist. All right, so with this, let's get started. Those of you who do not know me, let me tell you a little bit. My name is Anushri. I am an IIT Kharagpur graduate. I have been teaching math and physics for the competitive exams like ITG Advanced and NEET for the past 15 years. I love teaching you guys and I love seeing you guys get the concept, practice, work smart, work hard, and go score, right? Yeah, that's what we are all here for, to understand the concepts and have fun with the concepts. That's what all of our team at Khan Academy wants. Okay, so all of us here work very hard to bring top quality, top notch education to all of the students out there, everybody, for absolutely free of cost. Okay, so let's go ahead and get started. Here is the Khan Academy website. This is the website that we work with. The app is there as well. So, how many of you, Acha, by the way, how many of you are from JNVs? How many from OAVs? What's the ratio today, huh? We have a lot of, in the last session, we had a lot of JNV students, right? Very little OAV students. What is happening here? Huh? Okay. All right. Tell me, who all are from JNVs? Who all are for OAVs? Okay. And here, today's session is all about statistics and probability. As you might understand, yes, statistics, probability, both of them. Prob stats is what we call in engineering, right? That's the subject. So probability and statistics, it's again a very important pillar of mathematics. If you are planning to do engineering or if you're planning to do maths or any math related stream, you are going to want to have your concepts very clear. Okay, that's the idea. So prob stats, again, very important subject. So let's get started. This class is for grades 9, 10th, 11th, 12th. As I said, we are going to start with the basics and then we build on top of it. Okay, basics are going to be very clear. So here is the landing page of Khan Academy website. And how do you get the accounts? I hope everybody knows how to get the accounts, right? You have to get your accounts from your class teachers. Ask your class teachers, ma'am, sir, I want an account of Khan Academy. They'll give you a personal account and then you can change the passwords, make it completely yours, and whatever you want to learn here, you can come and learn absolutely free of cost. There is no paywall behind anything. All right, all the videos, all the worksheets, all the quizzes, everything. Okay. All right. And if your friends don't know this, do tell them as well, because again, right, it's better that you share knowledge. So there we go. Other than that, again, if by chance your class teacher does not have an account to give you, you don't need to worry. You can always create your own account by Just an email. That's it. That's all you need. You have your own email. You can create your account from that. You can come here and you can do all of that again. Okay. All right. I can see again. Oh, yeah, the chat's flowing. And here we have, oh, loads of people from JNVs. Huh? Again, in this also. Oh, yeah. Um, Hemalata says, yeah, you're okay. Okay. One OAV person. Everybody from JNV. Awesome. Okay. Where are the OAV folks? What are you guys doing? All right. All right. Uh, Kuver is from JNV Goindwal. Acha. Sunita is from JNV Kathua. Hardik is from JNV Indore. Okay. I'm from MP as well. So yeah. Uh, so Sukhmander Singh is from JNV. Fazilka. And then Ramesh is from JNV as well. Hardik is from JNV. Rishabh is from JNV. Wow. All right. A lot of students from JNV. Okay. Okay. Now here we are starting from ninth grade. We go to 10th grade. We go up. We go up. That's what we do. Okay. And in every grade, you will see this entire summary of your grade, right? So different chapters that you go to on the left hand side, you can see the list of entire chapters, right? Number systems, polynomials, coordinate geometry, and all of those. In every grade, you will have the list of chapters on the left hand side. And here in the center, what you have is course mastery, right? All of this tells you how many exercises you've done perfectly, right? How your levels are. And I want to know now, I'm very curious, how many of you have complete mastery? Yeah, what you know what I'm talking about here. How many of you have gotten mastered level for every chapter in your grade? Come on, come on, come on. That is something that's very exciting, right? Tell me. How many? How many over here? Yes, who is Bindas? Yeah, Rishabh, correct. Yeah, that's what I'm asking. All right, come on, brag. This is the place where you brag when you have entered master level, right? Okay. Now here we go to statistics, and as I said, today's session is all about statistics and probability. Okay. So first we do statistics, then we go for probability. Here we go to statistics, start with the basics of creating a bar graph. All right. And as we go in the entire session, just like other sessions, the format is that I will be showing you a video, and from the video, you will learn the concept. Once you've learned the concept, we'll go solve questions on the same concept so that, yes, we have fun and we have math and we actually learn the concepts, right? Yeah, fun way of learning. All right, let's go. How many of you are excited? And here is the first video, creating a bar graph. All right. Now, one more thing, very important. When the video runs, right, the voice, the sound from the video will come out. So I will not be able to speak. Okay. But I will be right here. And what I will do is I'll ask you with gestures. Are you hearing clearly? Everything good? Are you understanding clearly? All good? Yeah. And you have to respond in the chat to me. Okay. Keep telling me yes. If there's everything's good, you're hearing everything. If you don't understand anything, tell that also. All right. That's the deal here. Let's go ahead. Okay. All right. Let's go. Now, here we go.
20 teachers were asked 20 teachers were asked about their favorite course. 7 teachers said language, 3 teachers said history, 9 teachers said geometry, 1 teacher said chemistry, 0 teachers said physics. Create a bar chart showing everyone's favorite courses. So we have got the bar chart right over here, and let's see what we need to plot. So it said 0 teachers said physics, which is surprising to me since physics is arguably my favorite course. But let's plot what the data has. So physics, so right now it looks like it's halfway between 0 and 1. So you actually have to bring the physics down to 0. Let's see chemistry. Let's see. One teacher said chemistry. So we got to bring chemistry up to 1. Now 9 teachers said geometry. So geometry, let's bring that up to 9. One teacher said chemistry. Oh, I already read that. History. History. 3 teachers said history. So let's bring history up to 3, and then language. 7 teachers said language. So let's move this up to 7. And I think if I didn't make any careless mistakes, we should be done. Yep, very good.
All right, all right. Very, very easy. Very, well, I hope you understood, right? Did you understand how to create a bar graph? Yes. What do? We have any data. If we represent that data with bars on a graph paper, then that's called a bar graph, right? You need to have a frequency table to be able to represent a data with the bar graph. All right. All right. Let's go ahead. Let's go ahead and solve questions now. Yes? Okay. Let's go solve questions. Here we go. Now, with questions also, it is again the thing that we do with questions also is that I want you to be ready with your pen and copy. Are you guys ready? I am going to display a question, and yes, that's the game, right? We make a game out of it. So, as soon as I display a question, I want you guys to quickly solve it and then write your answers in the chat window. I want to see everybody's answers here in the chat window so that I can scroll back and check who answered the question right first. Okay. And that's what I'm going to call out. I'm going to call out the person's name who is the winner, basically. Yeah, because let's go. Ready? Yes? All right. All right. Manohar says you're in 8th grade. No worries. No worries. These are all concepts that are going to be useful. So keep learning, keep having masti. You're going to have some masti. Okay. All right. Let's go. Let's create bar graphs. Now there are 2 points to it. All right. First is if a bar graph is given, how do you read a bar graph? Read as in how do you extract information from a bar graph? The second is, of course, if the information is given in the form of a table, a data set is given, then how do you create a bar graph? Right? 2 parts to it. Reading a bar graph and then making a bar graph. So let's go ahead and read a bar graph first. Here's the first question. And the question is, ready? The graph shows the number of vehicles built at a factory last month. That's the graph. Here's the bar graph. X-axis shows number built. Y-axis shows the type of vehicle, right? So different vehicles are there. Bulldozers, garbage trucks, convertible motorcycles. And then we have to understand, we have to answer how many fewer bulldozers were built than garbage trucks and motorcycles combined. Okay. So how many fewer bulldozers compared to the garbage trucks and motorcycles combined? Got it? Got the question? All right. Let's see. Let's see who answers first. Here we go. So here is the bar graph. As you can see, I'm going to display the entire bar graph and the question so that it is very, very easy for you to see. All right. I hope everybody can see this. Oh, all right. All right. The answers have started coming up. Okay. Okay. I'm getting different answers here. Sahendra says 38. All right. Sahendra says 38. Snehal Davar says 20. Uh, Michikatsu says 20. All right. All right. Michikatsu says 20. Then we have Manohar Jopale says 20. Jashan says 20. Okay. All right. All right. I can see people giving different answers. One person says 38. Other few say 20. What else? What else? Gajendra is in the 38 camp. Okay. Gajendra says 30. 38. Kushi says 20. All right. Kushi Raghuvanshi. Who else? Who else? Come on, quickly calculate. What do we need here? We need to find out the difference between bulldozers and garbage trucks and motorcycles combined, right? So let's write the values first. We want the difference between, let me write it over here. We want the difference between bulldozers and garbage trucks and motorcycles combined. So garbage trucks plus motorcycles. These are the two quantities. These are the two numbers that we need to find the difference in, right? And now let's read it. From the bar graph, I can directly say how many bulldozers were created. The bars are going to give me yes. Okay. People are giving answers. Come on, come on, come on. What are your answers? Let's see. Bulldozers are these many bulldozers, right? This is a bulldozer. So the length of the bar is going to give you the number over here, the number of bulldozers exactly between 8 and 12, right? So here it is 0, 4, 8, 12, and so on. Exactly between 8 and 12, that means it is 10. So 10 number of bulldozers. Okay. Now we have garbage trucks and motorcycles. How many garbage trucks? Again, we read the data from the garbage trucks now. Garbage trucks are right over here and this bar goes only till 4. So garbage trucks are 4. Motorcycles are how many? Exactly, this is the bar for motorcycles. It's the longest one. Yes, any vehicle making company is going to create motorcycles more than other ones, right? Again, supply demand in the market. So we have here exactly between 16 and 20. That means 18. Exactly between 16 and 20, we have 18. So 4 plus 18 gives me a total of here, how much? 22. And we want the difference. How many fewer bulldozers were built than garbage trucks and motorcycles combined? That means the combined garbage trucks and motorcycles are 22. And how many fewer bulldozers? That will be 22 minus 10. That is equal to 12. Right? Is this clear? Yes? Okay, all right, all right. I can see people have started giving answers here. Khushi Raghuvanshi is the first one to give the answer as 12. 12 is the correct answer here. All right. So, Khushi Raghuvanshi is the first person to give the answer correct. Then we have Kuver Singh. Then we have Prakash and so on. All right. So, okay. Awesome. Awesome. Khushi and Kuver. Awesome job. Okay. Does everybody understand this? What are we calculating here? Yeah? Read the question carefully, see what you have to calculate, and for that calculation, see, we calculated 22 minus 10. But for the calculation, we needed to read the data, extract the data, right? From the bar graph. Is this clear? Yes? Everybody understands how 12 was the answer? Yes? Okay, all right. I can see people are understanding. Yes, awesome. Okay, all right. Now, do you want to go to the next question? Yes, read another bar graph, get the basics right, and then we move on to the next step. All right. Okay, let's go. Let's go. Let's go for a check first. we can't go to the next question till we put the answer in, right? We log the answer. We log the answer as 12, and then we go for a check. All good. All good. And now we go to the next question. Here we go. Here we go. Reading bar graphs. Let's go to the next question. Here's the next question. So, tell me again. I'm going to read the question. You guys quickly solve and give me the answer. Okay? Let's see who solves first. We have Alice graphed how many books in the school library are about her favorite subjects, right? So what Alice did was, in a typical nerd fashion, she went ahead and she graphed the type of library books, right? Her favorite library books. So the books that she graphed were, again, dinosaur, again, her favorite topic, insect, pirate, superhero. These are the different types of books that she reads. And here are the number of books that are her favorite. Okay. This is the bar graph that we have. Now, let's go ahead and look at the question. So, Alice has read 10 of these books. Okay. Alice has read only 10 of these books. How many books about Alice's favorite subject that she has not read are in her school library? Okay. So, how many books about Alice's favorite subjects that she has not read are in the school library? She has read only 10. How many not read books are still in the library? Got the question? Yes? Let's see what the answers are. I can see answers flowing in already. Okay, okay. So we have Different answers coming in. All right. Ravi Shankar says 110. All right. Ravi Shankar is the first one to give an answer, 110. Then we have a different answer. Acha, Ravi Shankar, you change your answer to 100. Okay. Then we have Mahendra Gena, 10, 100 answer. Again, Gurjot, 100. Or then we have Snehal Dabar, 110. All right. Then we have Jeshan Mehmi, 1900. Okay, that's a big number. All right. Then we have Ramesh Patel, 100. All right. Okay. All right. We have two things that are coming up, two numbers, right? Two possible answers, maybe 110, maybe 100. Let's see. Okay. The first people who gave the answers are, we have Ravi Shankar and Mahendra. Ravi Shankar and Mahendra. You guys gave the first answer. All right, let's see if this is correct or not. Everybody else. Okay, Vaswa Shankar says 200. Okay, all right, let's see. First things first. First things first. What do we need here? How many books about Alice's favorite subjects that she has not read in her school library? So, first things first, we want to find out how many total books are there, right? We'll say books that are total, right? Total will be in two categories, right? The ones she has read, already read, and the ones she has not read. This is not read. And what do we want here? We want this portion. So what do? We want this portion, the ones she has not read, right? So what do? We find out the total, and total minus already read will give us not read. Simple. Okay, let's go do the total. For the total, we need to read the bar graph, and we'll say total will be the books represented in each bar, right? So books represented here about dinosaur plus insects plus pirates plus superheroes. Correct? Okay. Let's see what the reading goes with the bar graph. Here we go. How many dinosaur books? Dinosaur books are exactly between 20 and 30. So 25. Plus, then how many insect books? Insect books are exactly between 10 and 20. So it is 15. Plus, how many pirate books? Pirate books are exactly 30. So we write 30 plus. Now we have superhero books. So superhero books are, yes, I love superhero books also. Have done since I was a kid. Yes. Okay. Superhero books. How many of you love superhero books? 40. So 40 right here. We have 25, 15, 30, 40. These are all the books, right? And this is how much? This is coming out as 30 plus 40, 70. 25 plus 15 gives me 30 plus 10, that is 40. Okay. 70 plus 40 gives me 110. And this is total. This is total 110. What do we need? Only not read. And the read data is given as Alice has read 10 of these books. So she has read 10 already. Total is 110. 110 minus 10 will give you the rest. Right? Very, very simple. So now what do we say? We say the answer for not read will be equal to 110 minus 10. That is equal to 100. Correct? Yes? Everybody gets it? Is this clear? All right. Okay. All right. All right. I can see a lot of people got 100 as the answer, and so many people who got 100 as the answer. Awesome. All right. Your answer is correct. And I already said who gave the correct first answer, right? So many people are giving the answers here. I think I lost the chat somewhere. But yeah, Ravi Shankar and Mahendra gave the answer right first. Awesome. Awesome, guys. All right. We have, okay. Are we good? Should we lock it? Let's lock it. Let's lock it. 100 books. That's the answer. All ready? All good? Okay. Let's go ahead and check. All good. Right? Okay. Let's go to the next question now. Ready for the next one? All right. let's go to the next question. And here we are going to increase a little bit, right? Go a little bit higher. Why? That's where the fun lies. We understand the concepts and then we go to the questions, one, above another, like that. Okay. So let's go and go for the next level of questions, that is creating bar graphs. All right. So till now you've seen how to read a bar graph. Now we'll create bar graphs. Okay. And you'll see there is a very, very fun interactive way in the website that you can create the bar graph with. All right. You'll see that. So first things first. Here's the question. Ready for it? The table below shows the favorite color of all the students at Wolf Elementary School. All right. Favorite color of all the students, right? This is the color blue, green, blue, green, red, yellow, pink, and so on. These are the number of students who like that color. Now, which graph below shows the most reasonable scale for the information in the table? So, here we have different scales. In order to create any graph, we need to figure out scale first, right? So, I will show you this very clearly and you will see which option is correct. Okay. All right. So the most reasonable scale. Are you able to see this? Or should I make it bigger? Okay. This is the first one. All right. This is the first one. This is the second one. This is the third one. And then that's it. Three options. Which is the best scale to use here? Okay. Option 1, option 2, option 3. Option 1 goes till 100. Option 2 goes till 300. So it goes with 50 difference, right? And option C goes with 120. All right, 15 ka difference. All right, all right. So first things first, let us look at the data here. What is the data? The data is the number of students who are liking these different colors. So we have 60 here. We have 105 here. We have 45, 90, 90. That means one data point is bigger than 100, right? So we can't go with less than 100, right? We have to have more than 100 in the scale. So what do we say? The first one does not work. This doesn't work. Why? Because 105 is one data point. It needs to be written here. So what do we do? Till here, A doesn't work. B goes till 300. That is too high. We don't need till 300, do we? No, we don't. So we say this is also not appropriate. Correct? What do we need? Till 105 or just above that. Right? So we go for the third one, that is still only 120. It is only till 120 and we're like, yeah, we can now put all the data in this scale. So this is the most appropriate scale, right? Option number C, the third option. Okay, all right. I can see Gajendra, first one to answer. Ravi Shankar, yes. Gajendra, Ravi Shankar, awesome. Prakash said C. Jashan, Jashmi, all right. Mahendra, Gulshan, awesome. Okay, let's go ahead and put the answer now. Okay, let's go ahead and put the answer. So here we go. Option number C is the correct answer. And did you guys understand why we are choosing the scale? Right? Because the scale that we choose has to be able to give, has to be able to put all the data points in there, right? We can put all the data points in this particular scale. All right. Okay. So 60, 105, 45, 90, 90, all of these can be put in this here. So option number C, let's lock it. Are you guys good? All right. Yes. Okay. All right. Let's lock option number C and go for a check. Yeah. Okay. All good. All good. Now, let's go ahead and go to the next concept. Did you guys understand how to read a bar graph? how to create a bar graph, and how to make sure you choose the correct scale for creating the bar graph. Yes? All right. Let's go. Let's go to the next concept. So, here we studied a little bit about statistics, right? We just started studying, and you should always continue it with the website, right? Go to the website and learn with all the videos and the exercises. Now, what we will do is we will go to the next chapter or the next concept, that is probability. All right. So, let's go, let's go, let's get to the basics of probability. Here we go. We have entered grade 10, and this is where the introduction to probability starts. Okay. And probability is such a beautiful, beautiful topic. You will see later on. Again, for those of you who are attempting JE, it is again very, very, very important, especially for the advanced and for main as well. And those of you who are going to go for engineering, as I said, probability statistics, one of the most fundamental topics that you need to master. Okay. So let's go to probability. And here as well, there are two types of probability. Okay. So one is practical probability, or you can say experimental probability, depending on the actual data that you have. And the other is theoretical probability, as in, if we didn't have any data, then based on the basic logic, what would be the probability? Okay. And probability here, let's go ahead, understand the difference between the two. Ready? Yes? Okay. Let's go ahead and start. Yeah. Intro to theoretical probability. As always, I will not be able to speak when the video runs. So as soon as it runs, tell me if the voice is correct. Tell me if everything's audible and so on and so forth. Okay. You're understanding everything. All right. Somebody says, Prakash says, start triangle, please, ma'am. There has been a session in triangles geometry, the entire geometry, okay? Go back to the playlist and you will find sessions on all the different units. Choose, pick, learn. Okay? Let's start.
Video is give you at least a basic overview of probability. What I want to do in this video is give you at least a basic overview of probability. Probability, a word that you have probably heard a lot of and you are probably a little bit familiar with it, but hopefully this will give you a little deeper understanding. So let's say that I have a fair coin over here. And so when I talk about a fair coin, I mean that it has equal chance of landing on one side or another. So if you can maybe view it as the sides are equal, their weight is the same on either side. If I flip it in the air, it's not more likely to land on one side or the other. It's equally likely. And so you have one side of this coin. So this would be the heads. I guess trying to draw George Washington, I'll assume it's a quarter of some kind. And the other side, of course, it's the tails. So that is heads. The other side right over there is tails. And so if I were to ask you, what is the probability I'm going to flip a coin? I'm going to flip a coin and I want to know what is the probability of getting heads. And I could write that like this: the probability of getting heads. And you probably, just based on that question, have a sense of what probability is asking. It's asking for some type of way of getting your hands around an event that's fundamentally random. We don't know whether it's heads or tails, but we can start to describe the chances of it being heads or tails, and we will talk about different ways of describing that. So, one way to think about it, and this is the way that probability tends to be introduced in textbooks, is you say, well, look how many different equally likely possibilities are there. So, how many equally likely possibilities? So, number of equally, let me write equally, of likely, equally likely possibilities. Of the number of equally likely possibilities, I care about the number that contain my event right here. So the number of possibilities that meet my constraint, that meet my conditions, that meet my conditions. So in the case of probability of figuring out heads, what is the number of equally likely possibilities? Well, there's only two possibilities. We are assuming that the coin can't land on its corner and just stand straight up. We are assuming that it lands flat. So there's two possibilities here, two equally likely possibilities. You could either get heads or you could get tails. And what's the number of possibilities that meet my conditions? Well, there's only one, the condition of heads. So it will be 1 by 2. So one way to think about it is the probability of getting heads is equal to 1 by 2. If I wanted to write that as a percentage, we know that 1 by 2 is the same thing as 50%. Now, another way to think about or conceptualize probability that will give you this exact same answer is to say, well, if I were to run the experiment of flipping a coin, so this flip, you view this as an experiment. I know this isn't the kind of experiment that you are used to. You know, you normally think an experiment is doing something in chemistry or physics or all of the rest. But an experiment is every time you do, you run this random event. So one way to think about probability is if I were to do this experiment and experiment many times, if I were to do it 1,000 times or 1,000,000 times or 1 billion times or 1 trillion times, and the more the better, what percentage of those would give me what I care about? What percentage of those would give me heads? And so another way to think about this 50% probability of getting heads is if I were to run this experiment tons of times, if I were to run this forever, an infinite number of times, what percentage of those would be heads? You would get this 50%, and you can run that simulation. You can flip a coin, and it's actually a fun thing to do. I encourage you to do it. If you take 100 or 200 quarters or pennies, stick them in a big box, shake the box so you are kind of simultaneously flipping all of the coins, and then count how many of those are going to be heads. And you are going to see that the larger the number that you are doing, the more likely you are going to get something really close to 50%. And there's always some chance, even if you flipped a coin 1,000,000 times, there's some super duper small chance that you would get all tails. But the more you do, the more likely that things are going to trend towards 50% of them are going to be heads. Now, let's just apply these same ideas. And while we are starting with probability, at least kind of the basic, this is probably an easier thing to conceptualize, but a lot of times this is actually a helpful one too. This idea that if you run the experiment many times, what percentage of those trials are going to give you what you are asking for? In this case, it was heads. Now, let's do another way, very typical example when you first learn probability. And this is the idea of rolling a die. So here's my die right over here. And of course, you have, the different sides of the die. So that's one, that's the two, and that's the three. And what I want to do, and we know, of course, that I'm assuming this is a fair die. And so there are six equally likely possibilities. When you roll this, you could get a one, a two, a three, a four, a five, or a six, and they are all equally likely. So if I were to ask you what is the probability given that I'm rolling a fair die? So the experiment is rolling this fair die. What is the probability of getting a 1? Well, what are the number of equally likely possibilities? Well, I have six equally likely possibilities. And how many of those meet my conditions? Well, only one of them meets my condition, that right here. So there is a 1 by 6 probability of rolling a 1. What is the probability? What is the probability of rolling a 1 or a 6? Well, once again, there are six equally likely possibilities for what I can get. There are now two possibilities that meet my conditions. I could roll a 1 or I could roll a 6. So now there are two possibilities that meet my constraints, my conditions. There is a 1/3 probability of rolling a 1 or a 6. Now, what is the probability? And this might seem a little silly to even ask this question, but I will ask it just to make it clear. What is the probability of rolling a 2 and a 3? And I'm just talking about one roll of a die. Well, in any roll of a die, I can get only a 2 or a 3. I'm not talking about taking two rolls of this die. So in this situation, there's six possibilities, but none of these possibilities are 2 and a 3. None of these are 2 and a 3. 2 and a 3 cannot exist on one trial. You cannot get a 2 and a 3 in the same experiment. Getting a 2 and a 3 are mutually exclusive events. They cannot happen at the same time. So the probability of this is actually 0. There is no way you can roll this normal die and suddenly get 2 and a 3. In fact, I don't want to confuse you with that because it's kind of abstract and impossible. So let's cross this out right over here. Now, what is the probability of getting an even number? So once again, you have 6 equally likely possibilities when I roll that die. And which of these possibilities meet my conditions? The condition of being even. Well, 2 is even, 4 is even, and 6 is even. So, 3 of the possibilities meet my conditions, meet my constraints. So, this is half. If I roll a die, I have a half chance of getting an even number.
All right, all right. So is this clear? Yes, everybody understood what theoretical probability is and how we calculate theoretical probability? Yes? All clear? If the video is clear and the concept is clear, how we calculate theoretical probability, then we go ahead and solve questions, yeah? Let's go solve questions. All right, all right. I have got your yeses and I know everything's clear. All right, let's go solve questions now. So, experimental probability, probability of complements, and simple probability. These are there. And then there is probability of an event. Okay. So let's go ahead and solve questions. So let's start with the first one and then we go move in order. Okay. As with every question, as soon as I display the question, as I have done, quickly get your answers, solve it, get your answers, put it in the chat. Okay. We'll see who answers first. So here we have March Madness movies served 23 lemonades out of a total of 111 fountain drinks last weekend, right? So March Madness movies, it's a movie theater. They served 23 lemonades out of a total of 111 fountain drinks last weekend. Now, based on this data, what is the reasonable estimate of the probability that the next fountain drink order is a lemonade, right? So reasonable estimate means what's the probability of them serving a lemonade again, right? I can see people are giving answers. Okay. Niharika said B. The first one to give an answer here is Niharika. Then Gurjor says B. Mohit Behra says B. All right. And then we have Mahendra. All right. Vaswa Shankar says B. Okay. And okay. All right. All right. A lot of people are saying B. And yeah, the first one to call out the answer over here is Niharika and Gurjot. Okay, Niharika, Gurjot, awesome job, guys. Okay, so what do we do? Probability of an event is what? The number of times that event occurs divided by the total number of events, right? Exactly. So here we go. Let's go ahead and substitute. How many times probability of a lemonade, them serving a lemonade the next time will be how many times have they already served lemonade, right? So how many times? 23 lemonades divided by the total number of times they served any drink, right? Okay. So total number of times that they served any drink is 111. 111 fountain drinks were served. So 111. There we go. We can say that 23 upon 111 is the answer here. We have option number B as the correct answer. Yes, very nice. Everybody got this? Yes, I can see people are getting the answers here. So, whenever we calculate probability, we always calculate how likely is that event going to occur out of all the different possibilities out there, right? That's the idea. Okay, all right. Let's go to the next question. Ready for the next one? Yes? Okay, let's go to the next question. Here I'm going to lock option number B and go for a check. Awesome. All good. We have a check. And now let's go ahead and go to the next question. Ready? Yes. Niharika says yes, ready. Here's the next question for you. And again, Read the question. I'm reading the question with you. Quickly solve it and tell me in the chat what your answer is. The following frequency table summarizes this year's injuries on the Canadian Rounders cricket team. Okay. Now, this is a table that's giving you the number of injured players versus the number of matches. And based on this data, what is a reasonable estimate of the probability that Canadian Rounders have 0 players injured for their next match? Right? So what is the probability when, what is the probability of 0 players being injured in the next match? Right? That's the question. Let's go ahead. Let's take the data. Probability of the event. Event here is 0 players injured. That's the event here. Okay. Probability of the event, 0 players getting injured. So now we go ahead and check. This will be, again, number of times the event occurred divided by total number of events that occurred. Right? Okay. Let's see. Let's see. Oh, so many people. So many people are giving answers. All right. All right. All right. What's the answer coming out? What's the answer coming out over here? All right. Here we have Gajendra. Gurjot says A. The first one to give the answer over here. Gurjot says A. Mohit Behra says A. Gajendra says A. Vasava Shankar says A. Mahendra Kana says A. Ravi Shankar says 20%, which is A. Yes. And Janvi Sharma says A. Neelam Kumari says A. Reena says A. Michikatsu Michikatsu says A. I'm sorry. Yeah. I can't pronounce your name, but yeah, thank you. Thank you so much. I hope you're understanding everything. All right. So, who says? Naresh Kumar says, oh, daily class hogi. Nahi beta. Right now, the daily class is not happening. Or, this is actually the last session of the summer session. Okay. I have had a lot of fun with you guys, but let's go ahead. Let's go ahead. Mark the answer. What's the answer over here? What's the answer over here? How many number of times did they have exactly 0 players injured? So let's see. 0 players injured were happening in 4 matches, right? 4 number of times. So we say 4. Out of a total of how many matches? Out of a total of all of these matches. So what do? We add them up, right? That gives us the total number of matches that happened, out of which there were 4 matches in which 0 players were injured. Get the concept? Okay. So for total number of events, we have to get the total number of matches here. Total number of matches will be how much? 4 plus 5 plus 2 plus 3 plus 2. 4 plus 5 plus 2 plus 3 plus 2. Correct? Yes? Let's go ahead, calculate this. We have 4 in the numerator, and then we have 4 plus 5 plus 2 plus 3 plus 2, 4, 5, 9. This is 5, this is 7. So this entire is 7. So 9 plus 7, 16. And we write 16. And now we say, 9 plus 7. Am I doing anything wrong? No, no, no. All good, right? So 4 by 16. 4 by 16 is actually 1/4, isn't it? This is 1/4. 1 by 4. So this is going to be 25%, right? The probability is going to be 25% here. So this is nothing but 25%. Yes. How do we calculate percentage? 1 by 4 into 100 gives us percentage, right? Okay. So we'll say over here, we have B option as the correct one. Correct? 25%. All right. Check the calculation, guys. Are you guys getting the same calculation? Huh? Did I miss anything? No? All good? The concept remains the same. So we have probability of 0 players getting injured is equal to the number of matches in which it happened already, right? The number of matches in which 0 players got injured upon total number of matches, right? Okay. All right. Yes, I can see calculations are all good. So now we go ahead and we put the answer. What do? Lock it. Lock it. Okay, I'm going to lock it. I'm going to lock it. You all said yes. Yes. Okay. Go for a check. Awesome. All good. And for all the questions out here in the entire exercises, in the entire worksheets and quizzes and everything, every question has step-by-step solution, detailed step-by-step solution with it, so that at home when you're practicing and you get confused and you want a solution, all you need to do is click right here at the blue link, and what you get is the entire detailed solution, right? So again, that's a very, very cool feature that I love. And other than that, in any question, if you get stuck somewhere, right, you read the solution, you see what's going on, but you still have doubt in the concept. You're thinking, I still don't understand the concept. So what do? Again, below the solution, scroll down, scroll down, scroll down, and what you find is the related content link. Okay, so you don't have to go here and there and search for concept. The concepts that are used in this particular question, in any particular question, will be listed right here. Okay, related content. You can go directly here, watch the video, get the concept clarified, get back right here and keep practicing. All right. I love this because it saves a lot of time. All right. Saves a lot of time that you might have wasted going here and there, asking for doubts, searching for content. You don't need to do that here. All right. Okay. All right. Let's go. Let's go. Next question. Next question. Okay. Here is the next question. Tiny's tattoo parlor sold 389 tattoos per month this month. 43 of those tattoos were arm tattoos. All right. So in this particular month, these were the total tattoos, out of which 43 were arm tattoos. Based on this data, what is the reasonable estimate of the probability that the next customer does not get an armed tattoo, right? So here, we don't want probability of getting an arm tattoo. We want a probability of not getting an arm tattoo. Okay. Not getting an arm tattoo. That is important. Does not get an arm tattoo. So let's go ahead and check. I can see people giving answers. Gajendra says B. Mohit says B. Niharika. Oh, okay. All right. Parinita says B. Hardik says B. Let's see. Let's see. Let's see. Come on. Take into account that we are talking about not getting an arm tattoo, right? So what do? We say either a customer comes in, they want to get a tattoo, right? They want to get a tattoo. Either they get an arm tattoo or they don't get an arm tattoo, right? Those are the two possibilities. Possibilities. If I talk about, then I'll say either possibilities of arm tattoo is either they get yes for arm tattoo or it is no for arm tattoo. No for arm tattoo. Correct? That's the only two options. Either a person gets an arm tattoo or doesn't get an arm tattoo. That's the idea. If they're getting a tattoo, they're getting it somewhere, right? So now we can say that the probability of not getting an arm tattoo will be 1 minus the probability of getting an arm tattoo, right? Because when we have exhaustive events, right? These are exhaustive events. These are the only two possibilities. There is nothing outside of this, right? So when we have exhaustive events, then we say the sum of all the probabilities of mutually exhaustive or exhaustive events will be adding up to 1. So here as well, these two probabilities will add up to 1. Yes, they are complementary events also, right? So we'll say, yeah, these are complementary events. Is either this happens or it doesn't happen. Probability of two complementary events, when you add up, they give you 1. So I will say no for arm tattoo, probability of not arm tattoo will be equal to 1 minus probability of yes arm tattoo. Right? That's the idea. So now let's substitute values. Probability of not arm tattoo will be 1 minus probability of yes for an arm tattoo. And what is a yes for an arm tattoo? The number of times people got an arm tattoo divided by total number of tattoos. That is equal to 43 upon 389. Right? Exactly. So now this becomes 1 minus 43 upon 389. That is 389 minus 43 upon 389, which is nothing but, what is 389 minus 43? Turns out to be 346, right? Yes, 346 upon 389. That is the correct answer. So probability of a person not getting an arm tattoo will be 346 upon 389. Is this clear? Yes? Did everybody understand this? What is happening here? These two are complementary events, right? Either one happens or the other happens. There is no third option here, correct? So you take two complementary events and you add their probabilities. You are going to get one, always. Okay? All right. All good. All good. I can see people are getting this. All good. Let's move on. Everybody understands this? We should log the answer? Yes? Okay, let's log the answer. Option number D is the correct answer here. We go for a check and all good. Okay, all good. Now, ready for the next one? Ready for the next question? Let's go. Yes. Here we go. Here's the next question. The following dot plot. Okay. The following dot plot shows how many pets each customer owned before entering Jeremy's pet stores today, right? So there are customers coming into a pet store and the data shows how many of these customers owned previous pets. Okay. Each dot represents one customer, and based on this data, what is a reasonable estimate of the probability that the next customer to enter Jeremy's pet store has exactly 3 pets? Right? So again, this is again a trend. A person who likes pets will have pets, and they will be again more likely to go into a pet store to get more pets. Right? That's the idea. A person who doesn't like pet will not enter a pet store. So again, it's a very good idea that, a very good assumption that any person who's entering a pet store would always already have some pets, right? Okay. Let's see. What are the answers coming here? I can see people have started giving answers. 0.23. Poonam Kumari says 0.23, which is option number C. Okay. Manohar says 3, which is option number C, I guess, because probability is not more than 1. It is always less than 1, right? Probability of any event. Poonam Kumari, Hardik Kamble says C. All right. And C. Okay. All right. All right. I can see the first person to give this answer over here is Poonam and Manohar. Poonam and Manohar, two people who gave the first answer. Okay. All right. All right. Let's go check. What is a reasonable estimate of the probability that the next customer to enter Jeremy's pet store has exactly 3 pets? Probability of having exactly 3 pets. Having exactly 3 pets, right? This is the event that we have defined. The event is having exactly 3 pets. Probability of any event is what? Again, we are talking about experimental probability here, not theoretical, right? So what we do is we go ahead, right? How many times has this event already occurred in a bunch of how many total events, right? So here we go, having exactly 3 pets. That means number of pets is right here. So 3 pets is exactly over here, right? This is 3 pets. How many people had 3 pets already? Each dot represents a person. So 1, 2, 3. 3 people, 3 dots. That means 3 people had exactly 3 pets when they entered the shop. Okay. 3 divided by total number of people that entered the shop, right? That will be how much? All the dots, right? So let's count all the dots. How many dots do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 people out of 13 people who came into the shop, 3 people had exactly 3 pets already, right? So we say having exactly 3 pets, what's the probability? 3 out of 13, right? 3 divided by 13, and what is that? Think about it. All right. 3 divided by 12 is 1/4, which is 0.25. So it should be a little less than 0.25, right? A little less than 0.25. That means 0.23. So my gut says 0.23 because 0.1 will be very less. It will be just 1 by 10. And 0.30 is greater than 0.25, right? So we don't really need to calculate also. I can directly say, yes, this is going to be equal to 0.23, 0.23, because those are the options, right? Okay, all right. These estimates you can do, and yes, get away with not doing a lot of calculations, right? Okay, so here I can say directly, yes, option number C, 0.23 comes out. And did you understand? Yes, having exactly 3 pets, probability will be the number of people that had 3 pets, that is these 3 dots, divided by the total number of people that came in, that is all the dots combined. Correct? Okay, all right. Let's lock it in. Let's lock it in. Option number C is the correct answer. Uh-oh, uh-oh. Okay, let's lock it in. And we go for option number C. Go for a check. Awesome. All good, all good, all good. We are good with it, right? And with this, I didn't even realize the R went up just like that. I hope you guys had a lot of fun. Yeah, tell me how many of you had a lot of fun in this entire series, because as I told you, this is the last session of the series, right? So do tell me how was did you have fun? Do you want any other sessions like that? What would you like to learn? Okay, do tell us that also. We would like to know what you would like to learn, what you would like more to practice or more to learn, right? And if you have any questions, any doubts, just write it in the comment section. Our team will again take care of it. If you haven't attended the previous ones, there is a playlist out there. You can go ahead and check that out, and make sure to do exercises. Okay, after every session, I ask for a promise for exercises. Now tell me how many of you have done the exercises and still promise to do further. Okay, you will find the link to the exercises in the description below. Okay, so take that exercise, make sure you learn, make sure you practice, make sure you have a lot of fun. This is summer and we are doing Masti with math. And make sure that, yeah, you just, work hard and work smart also. Because yes, grade 9, 10, 11, 12, you got to work hard and smart, right? Until next time, happy learning. Bye bye. Bye. This was amazing. This was a really good experience. Bye bye.